object.
That's crazy.
Okay? So you can see how the curved space is allowing for basically a moon to orbit another, oh, that didn't work out too well. We got lucky with our moon, I gotta tell you.
Yeah. Really weird.
So that was pretty neat how he was able to throw both of them. The smaller object, it still orbited the center mass, but it also orbited the larger object. Because it's hard to see, but there's a little dimple of that larger marble created that the smaller marble can stay in as it moves. Oh. So you can start to see, I hope, visually how curved space can explain all of these types of motion that we explain with an apparent force of gravity. And it's really just curved space. Here he goes. He's got his two massive objects. He's going to plunk down in here. And you're going to get what kind of an orbit? What kind of an orbit might you be able to create? A figure eight. Okay? So here we go. Let's see if he's successful. Oh, he's got to go a little faster. And he's getting, and then it crashed. Okay?
That's why we don't have two suns.
Yeah, that's why it's a good thing not to have two suns, right? Yeah, one's more than enough. Or actually, not more, but sufficient. It's good. It's good to have one sun. Oh. Which is why, in all honesty, Star Wars, okay, when they have those two large moons, okay, and then they have this climate that everybody can walk around in that are humanoids, a bullshit. I'm sorry. A bullshit. Okay? Those two moons at some times would get on the same side with each other, and they would mess stuff up, wouldn't they?
Yeah.
Totally. But it looks cool. That's the whole thing, as I was saying to Dwight the other day, it could happen. You know.
What if they're both like in the same orbit speed, where they were constantly like keeping
perfectly
where they were like
done at the opposite sides,
yeah.
Then you would have no tidal motion at all.
Wait, did he put something?
Oh yeah.
Yeah.
So yeah, he created another warp in the space, so he's got a stick underneath. And
What's
you can
that?
see, you could have, you got fun with flags. Well, this is fun with stretchy fabric. And he's got one more to go here. What's he doing? He's got, there he's doing his moon again. And what else you got in your bag of tricks here? Oh, now he's got what? These look like, kind of like gas, but gas giants usually have a greater mass. These might have a large volume, but they're not very dense. Those little, the larger balls that he threw in there. They're not happening.
It's like they're playing tag.
Okay, here's the last one, the holdout. Everything finally is going to spin down into itself.
Don't forget about the sun and when it dies.
When the sun goes nova?
Yeah.
Yeah, supernova. Okay. I'm going to do this, and then I need to go and do this one, and this one we're going to have to listen to. So you're going to need... Shh, silence! I really do need for you to be a little bit quiet here, because you're going to want to follow this. I can also go back and explain after the fact. Are we done sneezing? I know you can't control sneezes. I can't either. Okay. Shh.
Like, what do you do? Get yourself in the
Okay, now we're going to connect that curved space idea.
And long before Einstein, the quest for unification began with the most famous accident in the history of science. As the story goes, one day in 1665, a young man was sitting under a tree when all of a sudden he saw an apple fall from above. And with the fall of that apple, Isaac Newton revolutionized our picture of the universe. In an audacious proposal for his time, Newton proclaimed that the force pulling apples to the ground and the force keeping the moon in orbit around the Earth were actually one and the same. In one fell swoop, Newton unified the heavens and the Earth in a single theory he called gravity.
The unification of the celestial with the terrestrial, that the same laws that govern the planets in their motions govern the tides and the falling of fruit here on Earth. It was a fantastic unification of our picture of nature.
Gravity was the first force to be understood scientifically, though 3 more would eventually follow. And although Newton discovered his law of gravity more than 300 years ago, his equations describing this force make such accurate predictions that we still make use of them today.
In fact, scientists needed nothing more than Newton's equations to plot the course of a rocket that landed men on the moon. Yet, there was a problem.
there.
While his laws described the strength of gravity with great accuracy, Newton was harboring an embarrassing secret. He had no idea how gravity actually works.